So in this section, we will discuss intersection between two planes. Now, in our previous sections, we discussed about planes. So let me revise what we really discussed. We discussed about this where we have a normal vector that can be n vector. There is a point here. It's a given point, and this point is R, where you have XYZ coordinates, arbitrary point on the plane. So this is a fixed point. So we define our plane by using this R dot n, A dot n. This A dot n we wrote as K. Now this is called the vector equation of the plane. When you properly taught this, then we can simplify this into Cartesian equation of the plane. You get the Cartesian equation of the plane when you simplify this. When you simplify this, you get the Cartesian equation of the plane. Example can be 2x minus y plus k is equal to 3. So you have to understand this part you get from here, and this part you get from here. So R in this case is xi plus yj plus zk. N is 2i minus j plus k, so that you can extract from these coefficients over here. That is what we discussed, right? Now, angle between two planes. Angle between two planes. So that would be like this. You have one plane like this, and you have another plane like this. Then this plane has the normal vector, I would say n1, and this is going to be pi1. The normal vector to this one is n2, and this is going to be pi2. Then what you need to find the angle between those two planes, So angle between those two planes are equal to the angle between the normal vectors, right? Because if you construct this, n1 looks like this, and if you bring n2 here, then this angle is the same as the angle between two planes, right? So what you have to do essentially, if you need to find the angle, you always do the dot product. n1 vector dot with n2 vector, and that would be n1, n2. n1 is nothing but the mod of n1 vector and n2, then cosine theta. So from here easily you can find theta, which is going to be cos inverse n1 vector dot n2 vector divided by n1, n2. So this is how you find the angle between two planes. Okay, so this we know. Then intersection between two planes, right? Think about, you have a plane like this, and you have another plane like this, where this is going to be pi 1, this is going to be pi 2. So intersection between two planes. Intersection looks like what? Intersection looks like what? Intersection is a line, right? Intersection is a line. Now let's try to figure this out. Suppose you have this plane, 2x minus y plus k is equal to 3, not k, z. This one, minus x plus y plus 2z is equal to 1. Yeah. So now when two planes are intersecting, think about two lines are intersecting, linear lines. So two lines are intersecting means it's a simultaneous equation. So you can solve simultaneous equation, two variables, two equations to find x and y. Here, you have two equations, but you have to find three unknowns, x, y, z. Right? You have to do that. So what we can do, now to find the intersection, need to solve pi 1 equation with pi 2 equation. Right? So basically, 2x minus y plus z is equal to 3 and minus x plus y plus 2z is equal to 1 need to solve. Now, how do you solve these two equations simultaneously and they have three unknowns, two equations? There is no way.
Since the intersections are line, won't there be a variable that doesn't matter if you solve for?
I didn't get you.
Like the intersection of the two planes is like a linear line. Won't there be a variable that you don't really need to solve for?
So,
You can solve for the other two with just two equations.
so when you have a system, what typically we do is we let z to be a constant lambda. We consider that let lambda to be a parameter. Then 2x minus y plus lambda, actually 2x plus y is equal to 3 minus lambda. Then minus x plus y is equal to 1 minus 2 lambda. So these two, now you are going to solve for x and y and in terms of lambda. So then you can easily add these together. So when you add these together, you get x, right? Then you get 4 minus 3 lambda. Right? Then y you can find, that would be 1 minus 2 lambda plus 4 minus 3 lambda. So that would be 5 minus 5 lambda. Yep. So we got now 3 values for x, y, z in terms of lambda. So you got this, you got this, and you got this for these values. Right? Now what we do, you have x, y, z. Right? You have x, y, z. Now what he mentioned, when you have two planes intersecting, now when at that moment, what you are going to get is a line. Like for example, you have two linear lines. Two linear lines will give you a point. Two planes will give you a line, right? So suppose that line looks like this. Suppose that line looks like this. This is the line. This is the line. So this line is due to this intersection, right? So this line has points. This line has points, right? This line has points. Now, what is the physical representation of this XYZ? This XYZ is the coordinate of a point here, XYZ. XYZ is the coordinate of a point on the line, correct? So that makes sense. The reason for Z there is a parameter. X and Y there is a parameter. When you change the parameter, this point becomes this point. That point becomes this point. That point becomes this point. So you can make unlimited number of points, coordinates on the line using this lambda parameter, right? So that's the logic. Now, since I have the picture here, what I'm going to do, now once you know this coordinate over here, once you know this coordinate over here, you can find the position vector. Why? Because always you can consider a origin and then you can find the position vector. That position vector is R. Okay? That position vector is given to you as xi, yj plus zk. That's how you find the position vector. Right? X, y, z are the coordinates. So x value and y value and z value, you substitute from this part. So x is going to be 4 minus 3 lambda I plus y is going to be 5 minus 5 lambda. Then lambda k. What I'm going to do now, lambdas I'm going to group. So if I do that, I get 4i plus 5j plus lambda minus 3i minus 5j plus 1 plus k. This is my R of lambda now. Right? Now look at the beauty. This has the form of A plus lambda d. Look at the beauty. A plus lambda d is a equation of a line. So ultimately, we derive an equation of a line by considering two planar intersections. So A is a point on the line. So you can consider A to be here. So that means this is going to be A in this case, and this is going to be R of lambda in this case. Okay. So this is how you typically find the intersection line when two planes are coinciding each other.